This project ended up being far more epic than I envisioned. I'm pretty sure that you get inspiration from one or more things that I'm going to show in this video. This all started when I made a stupid mistake. I upgraded my computer to increase my productivity for the increasingly higher complex designs and higher quality videos I want to produce. Also to play the casual game to wind down and relax a little after a long working day. This CPU gets hot. So my dumbass thought, let's buy big and high RPM fans without realizing that these things are fucking loud! Like insanely loud. This is not funny anymore. This thing drives me crazy. I cannot even have a decent video call anymore. Joel, can you...
Yeah.
You can hear me, right?
Barely.
Okay, it's my PC. It's quite hot here, so I have a bit of a noisy PC here. So instead of buying more silent fans and accepting my defeat in poor decision making, I thought, let's buy an IKEA cabinet. Try to make it soundproof with a fuck ton of foam and see how it will end up. Well, here is the IKEA cabinet. It misses the door, I'm still waiting for a hinge. But I had a lot of fun putting this thing together. Yeah, okay, let's modify this thing. Projects like these are honestly the most fun to do. I made some simple drawings and 3D printed these templates that I can use to mark the holes that need to be cut out. It's hard to explain, but there is something very satisfying about using templates like these. I punctured the 4 dots with a scriber, so I can center the holes that must be drilled. It doesn't need to be the cleanest job, so I can just use a flat drill bit. Okay, I know. I should have clamped an extra sacrificial piece of wood below it, not to butcher it like this. Too late now. Now it's pretty easy to cut the rest with a jigsaw. I can hear you thinking, this looks bad. And you're right, it does. I'm going to polish this dirt so good that you can see yourself in it. That's the beauty of 3D printing. I removed the back plate because it's too thin for our purpose, and I bought a furniture panel that must be cut to length. Okay, don't ask. This is how we do things here. You know how the saying goes, right? Measure once, cut twice. Oh, wait. Usually it goes more like this. Maybe measure once more. How hard can it be? Oh well. We've got the cabinet here. I used the original backplate as a template to mark out these holes and drill them out. Found some thick screws that I cut to length, countersunk the holes and made the same rectangle holes as I've shown earlier. Filmed some sick ass slow-mo shots, put everything together and tried to hide my mistakes. Now we're here, and in all honesty, it looks like shit. I didn't feel like doing the perfect job because I'm going to hide it anyway. with these 3D printed grills. And I printed these on the Prusa MK4 out of flexible material. The reason why I printed this out of flexible is because when I bump it into something, then it doesn't break. And the second reason is that it might help dampen the sound even a bit more because it's a softer surface. So these holes are for ventilation, but I don't want to get dust sucked inside of this thing. So it needs some kind of filter. And I was thinking about purchasing these standard filters that you can also use for your PC and laser cut them to the right size, because that's cool. But then I saw that basically all of them are made out of PVC, and that's the last material you want to cut on a laser cutter. So then I came with this, I think, pretty interesting idea. 3D printing my own filters. This is inspired from the work of 3D Print Bunny. She makes some interesting designs where she uses 3D printed strings to suspend things. It's pretty cool, you should definitely check it out. And I thought maybe I can just print a bunch of these strings next to each other and then perpendicular on top of that the longer strings and create myself some sort of mesh. Well, it took a couple of iterations. Some of them actually turned out pretty good, others interesting, but I was very close to cracking the code. While I was working on this, in the meantime I went to Make a Fair Prague and we had this weird bike that no one could ride. I also want to try it, looks like it's possible. And I tried, and the very first time I just aced it, like I always do.
Welcome to Proper Print Channel. I'm John.
And I also talked to Joseph Prusa about this side quest I'm having. And what he said is that after the event, just hit me a message. I might have some suggestions for you. That's what I've done. Sent him a message. And then he replied with this. He suggested using the slicer, making the mesh, using infill. I was like, okay, that's interesting. I can see that you are approaching this from the slicer perspective, which makes sense. I am from the designer's perspective and just use the slicer to, well, slice this stuff. I didn't think too much of it. I was like, this is just a way more elegant way of making meshes, in my opinion. So and then I thought, who would have the best solution here? This guy, the man whose name is on the actual 3D printer I'm printing this on, or Johnny from Vlachtwedde? Hey. So I tried Joseph's suggestion, and it's absolutely bloody perfect. It's insane. This is... So I printed a ton of these, all filters. All of them they came out just perfect. And I also went one step further and turned the picture, the image that also is the logo of this channel, into this picture frame. And this is just an infill at different percentages, and you can really see the gradient. And I think that this idea has some real potential, especially for customizing PCs, like gamer PCs. Imagine making your own 3D printed filters with your gaming avatar or logo. I think that you might be onto something here. Okay, there's one more thing I want to show you, and that's these caster wheels. I thought that I needed to design and 3D print some adapter mount, but when I went to the hardware store, I found out that you can just remove these, and they are just selling, well, these things. They happen to have the perfect thread for it. It's pretty cool, right? Okay, now the wheels are put under there, I need to show you something awesome. This is the ZimoBoard 832, which is a single board computer that features a PCI Express port and SATA ports besides the usual connections. So when they reached out to sponsor this video, I couldn't say no, of course. They didn't ask for it, but because this product is also for tinkerers like you and me, I designed some things for it. I laser cut this bracket out of smoked acrylic to match the original style and added this 7-slot PCIe Express USB card to it. You cannot have enough USB, and this whole package looks great. This board will be my personal file server, so I designed a hard drive bay, bought a 20 TB disk and connected that to the SATA port. Now it's time to boot it up. I found the IP address on my router, but I could just have entered Casa OS in the browser. The Zima board is pre-shipped with this OS that runs on Debian Linux. At the first boot it asks you to create an account. It immediately detected the hard drive and it was already finished before I could enjoy my coffee. You can install a bunch of apps to create your home server. You can connect it directly to a TV or monitor to turn it into a media server. It runs on an Intel Celeron processor, so it's basically a regular PC that can also run Windows. I'm using it as a file server that is also synced with Google Drive. There are just too many epic use cases for this board to cover in this segment. Explore them yourself by clicking the link in the description of this video. Thanks to Zima board for sponsoring this video. I 3D printed custom cable grommets out of two different materials, ABS and TPU, and these two materials bond really well, which I demonstrated with this failed print. Usually it's hard to combine these materials, but the tool chain system of the Prusa XL made this possible. Before you ask why I didn't use the multi-tool printer I just developed, well, it's under construction, alright. I mounted the grommets and it was easy to hold them in place like this. The next step was to add these foam seal strips. I 3D printed a simple tool that enabled me to cut an accurate 45-degree angle that made the corners sharp. This part is the base for the closing mechanism. I used flanged nuts in reverse and pressed them in at the bottom. This made it easy to mount the parts to it. One of them is this bracket, and together with this switch, this is basically a mechanical OR switch. I also added these push to open latches that will hold the door shut. I made some simple risers on which the LED bar can be fitted and mounted the doors to the cabinet. I used the doors to align the closing mechanism assembly and mounted this with regular wood screws. The latching mechanism works and the seal strips act as a spring so the doors stay firmly shut. It looks like this OR switch function is going to work. I mounted the LED bar and connected the existing cable to the switch. The light turns on when the doors are open, they stay on when one door is closed, and they turn off when both doors are closed. I found this power strip that can be mounted in a corner. I took it apart and connected a power cable to it. Then I mounted this inside of the cabinet, so we have our power hub in there. Okay, the PC will be suspended by cables for two reasons. One of them is that it's very impractical to place the PC directly on top of this foam. And the second one is to reduce contact noise. I have this plate and the initial idea was to mount these four corners to it. And these things are printed out of PETG with carbon fiber, which is pretty stiff. And to reduce the contact noise even more, I had the idea of using this spring, but I quickly found out that this is a lot of hassle. And then I realized that we have this multi-material solution here that I've shown earlier, of flexible and rigid material, just like the cable grommet. This is a combination of ABS and TPU that bond so well. This is not the most flexible TPU, so it's pretty hard to flex. But yeah, we're going to suspend the whole PC so it mustn't flex too much. And I hope that this will dampen the sound even more. And also it looks cool, of course, and I think that this is a pretty cool use case for this printer. This was a pretty tough print. These corners started to lift, so I added some cylinders at the ends to increase the bed adhesion a bit more. And bed adhesion there was, and I used a pretty interesting infill for this TPU part, which I think would work well with how this deforms. Let's mount this stuff on this plate and suspend the plate in this bad boy. I pre-drilled holes in the plate to make it easier to align the corner pieces and mounted them on there. I prepared the ropes that will suspend the plate for the PC to stand on and screwed in the plugs for the top plate of the cabinet. Instead of the plastic dowel pins that go in there, I added these hooks that have similar dimensions. These hooks should hold the PC and it's pretty easy to push the ends of those ropes in there. Okay, I'm very happy with how this is turning out, and now it's time to add the foam to it. As you can see, there is already a lot of stuff in there, so we have to make some custom pieces. And luckily I have made a CAD design of this whole thing, or as the fancy people would call it, a digital twin, which we can use as a reference for making these custom pieces. I made sketches of the outlines of the foam pieces in Fusion that I could export as a DXF file. This file can be imported into Affinity Designer or Inkscape and can be saved as an SVG file for laser cutting. I had a clear system where I numbered each piece of foam and I had no spare, so I cannot make any mistakes. I placed this on the laser cutter, the X-Tool P2, which is a 55 watt CO2 laser cutter that has no issues blasting through this stuff. If there's one thing you can take away from this video, let it be that you can use wallpaper adhesive to mount foam panels. Like seriously, this has almost only advantages. It's cheap, easy to work with, it doesn't smell, and if you spill it, it's easy to clean. You can still adjust the panels after they are placed, yet it holds position. I also used this for my studio wall, where I placed all the names of my top tier Patreon supporters and gold members. Thanks guys for your support. I mounted the bottom and side panels and the cabinet was starting to get heavy. Also, the tricky panels at the top fitted perfectly and the panels on the doors weren't a problem either. Last step was to remove the excess adhesive, which was easy to do with a piece of paper towel. I bought a ton of silent 120mm fans, which I prepared by adding grills. I placed them in such a way that cold air is drawn from the bottom and pushed out at the top. I was thinking about making extension cables, but Noctua sells these as well, and I connected everything to an 8-channel fan hub together with a fan controller. The bottom plate fits just perfectly and I think that this looks epic. Okay, my initial idea was to not use fans at all and just hope for the best. But then again, who am I kidding? The heat is not magically just going out of there. But I didn't want to go through the trouble of finding a way to mount the fence in there. But then I saw in the CAD file that the space between this face here and this in this foam is 110mm, which is just perfect for just placing 120mm fence in there without having to make any kind of mounting system. So that's pretty cool. But there is one problem though. When I place the PC in there and this thing is standing on the ground somewhere below my desk, I don't want to crawl under there and open it up each time when I want to turn on the PC. The solution turned out to be one of the most epic things I've shown on this channel. I have this remote camera shutter that I took apart even before I started this project, and this is probably the best idea of this video. I reached out to my YouTube colleague Hendrik, who I met at the Sanjay Mortimer RepRap Festival last year because I needed his help for this. He has a YouTube channel on which he electroplates 3D printed parts. The things he does are just amazing and I highly suggest checking that out. I designed an enclosure for the remote shutter with the goal to turn on the PC remotely. Hendrik and I discussed the design and then I started printing. I printed at an extremely high resolution on this Anycubic Photon Mono M5S Pro with a 12K LCD display. This printer comes with a heater that is useful for high performance resins. The resin I used was tough and a bit flexible. For this purpose though, I need a part that doesn't flex, so I ended up with this Craftsman grey resin that came out nicely. I put it in a package and handed this over to Hendrik. He sanded the part and started coating it, and in the meantime I prepared the electronics and figured out how it worked. This is not just editing, we literally did this in parallel. If you want to know how this process actually goes, you can check out his channel and subscribe when you're there. Now it's time to put everything together, and I was very careful not to scratch or smear it. I covered it during soldering to prevent flux spatters and carefully added the stainless steel knob to it. I added the batteries that also added some weight to this thing, and now the LED ring lights up when it's pressed. I punched the holes in the rubber feet so I can stick these on the countersunk screws and still be able to mount them. It is insane how good this looks. I kid you not. At this point I still didn't really know if this would actually work, so fingers crossed. I found a 3.3 volt connection on the motherboard, and it would make sense that this is always there considering its function. This can be used to power the receiver, which runs at 3 volts, which is just slightly lower. So I connected the receiver to this header and made sure that the original power button also worked. My hands were shaking because it would be so terrible if this whole idea didn't work. Well, here goes nothing.
Yeah! Yes!
This was such a relief. It works. This is so epic. I don't understand why this is the common thing. You can find wireless remote power buttons, but they are not common and don't look great. Even if I didn't have made this cabinet, this would be an epic addition in my opinion. Okay, talking about that cabinet, let's put it under the table and place the PC in there.
Als die nou niet...
If it fits.
Meen je dat nou?
Ja.
Krijgt de tyfus ook maar.
Okay, this video is already filled with last-minute impulsive decisions, and I decided to just start removing obstacles. In this case, the damn table that isn't high enough. I just received a new table from a future sponsor, which I already had to place there anyway, so I figured that this is the perfect moment. Yes, I'm realizing that things are escalating a bit here, but it's all for the better. I assembled the whole table, placed it at its new location and mounted the monitors. I made neat cable bundles and guided them to the cabinet in which I placed the PC. Now let's turn it on. It should be silent. Okay, I'm going to be completely honest with you. It is not as good as I hoped. This, my friends, is what a loser sounds like. So I ripped out the fence, it was already a lot better in the cabinet, but there was this constant pitch that I could not get rid of, unless I placed the PC outside or in the other room. I also removed the water cooling that was in there because it underperformed and also wasn't that silent. And I replaced that with different water cooling that I initially didn't buy because it's too big for this case. But I just made some mounting brackets for it that actually fit pretty neat with this clamping system and these thumb screws. But now we have a radiator sticking out, but it's inside the cabinet anyway, so you don't see it. So I turned it on for a quick test and well, I honestly couldn't believe it. I had to check if the fans were actually running. So yeah, I placed it back inside of the cabinet to make it dead silent, and now I have a super clean silent setup with the best looking power button known to man.